Hello and welcome to another episode of James Dean Designs. Now the cat's out the bag, although it was never really a secret. The new CNC I'm going to be working with is the LongMill MK2 4830. Now this is a pretty big machine in compared to what I am used to. Arguably I should have been finishing off the build of the new workshop, but I'm really eager to get stuck into this machine. So that's what we're going to be doing today, is getting all of this assembled. Now before we dive in, a very quick tip. Make sure you have something like a tablet or laptop to hand with the latest LongMill assembly guide downloaded. Now obviously even if you're following this video, they may change things over time, and that will give you the most up-to-date information in regards to the assembly. Now obviously the first thing we need to do is get everything unpackaged. I've already taken some things out of the main boxes, but we're going to get all of this unpacked, check everything is there. Now when you are unpacking, they do a really good job of hiding things inside of other things, obviously for storage and to keep it as compact as possible. So do make sure when you unpack everything, you are checking inside of every box and every gap to make sure every part has been taken out. So let's get this all unpacked and we can start the assembly. So that is everything unpacked, and as you may have seen in that quick clip, little things like the lead screws are hidden inside the drag chain, and that's what I was referring to in terms of making sure you check everything. There's also some empty boxes in the packaging, obviously for protection, but obviously do make sure you open and check everything to be sure. Now if you have space, put everything in some sort of logical order. So I've got the framework over here, I've got electronics over here, and some nuts and bolts and things all together as well. Anything like accessories, put those to one side for now because you don't need them, and just keep those safe. Now the next thing we need to do is to start assembling some of the smaller parts. So we're going to start with this green bag here, or clear bag with the green label I should say. We're going to open this up and start to build some of the pieces in this. So let's zoom in a little bit closer and get this done. Now the next step is to assemble the anti-backlash nuts. For these you will need the Derelict anti-backlash, you will need the nylon M5 locking nuts, and you will also need the M5 16mm bolts. Now this is fairly simple to do. We take the little nuts, nylon washer side facing upwards, and drop them into the hole. They are already designed to a hexagon, so should go in nice and easily. However, they are a little bit loose, so do make sure they don't drop out once you have got them in. Then you want to take the M5 16mm nut and just thread that in part the way, just to make sure it is in there nice and secure. So nice and easy, and we're going to do that for the rest of them. Now I should say there are spares in here, so do assemble them, but just do keep them safe. You may not use all of them, but it's good to have them pre-assembled so everything is together. So with those assembled, we're just going to stack them up, put them to one side for now. As I say, you won't need all of them, but it's good to have them pre-assembled so you can keep them together. And we'll move on to the next step. For the next step, we need the Z-axis end plate, which looks like this. We also need two flanged bearings. Now there are two different size flange bearings, so just for clarity, we need the smaller ones and we'll put the larger ones to the side. So we need the smaller out of the flange bearings, and these just simply pop into the large holes. They will only go in one way, one on either side. They are identical, and then obviously that should swing nice and freely. These can drop back out, so again just put that to the side and make sure none of the bearings drop out. Next you're going to want the hex key that comes in your welcome pack. You're going to want the shortest T8 lead screw for the Z-axis. This comes attached to the two longer ones and is the thinner out of the different types of lead screws. You're going to want the locking nut. We want the Z plate that we just assembled, and also one of these black couplers as well. And we're just basically going to put all this together to make it one piece. So the first thing we will do is take the lead screw and we're going to thread the locking nut onto this. Now the locking nut does have a flat side and a tapered side, so I'm leaving the tapered side pointing away from me at the moment. Take that in maybe 1 to 2 inches, and then we're just going to slide it through the Z assembly plate, put that in place, and finally bring the coupler in. Now the coupler has two holes, a smaller hole and a larger hole. The larger hole should go onto the lead screw. Push that in until it can't go any further. Then bring your hex key in and tighten up just the bottom bolt, the one that is over the lead screw. So I'm going to give that a few turns. Make sure that starts to tighten up. Once it starts to pinch, just make sure it is holding nice and tight. A little bit of extra pressure, and make sure it is not coming off. Now once that is on there and secure, we want to slide this all the way back up so that the Z plate is now touching it, and then turn this a few turns to make sure the locking nut now touches up to the bottom of the bearing. Again, once that is in place, bring your hex key in, give it a few turns and start to tighten that up. Now once that is assembled, that should be clamped quite tightly and there shouldn't really be any movement. There may be a slight up and down wobble, but there should certainly be any left to right movement. If there is, tighten that up a little bit more and clamp it all together. But ultimately it should still be able to rotate and spin freely, as we can see here. Next we are assembling the V wheels. You will need the M5 25mm bolts. These come pre-assembled with a locking washer and a flat washer. You'll need the other pack of M5 flat washers. You will also need the V wheels as well. Now assembly of these is very simple. First take the wheel itself. Now there is a little washer inside of there. Make sure you can see all the way through. If you can't, take something like your hex key, push that through to align the washer in the center, and then you should have a good clear hole to place the bolt straight the way through. Once that's gone through, take one of the spare flat washers, place that over the top, and that is assembly of that done. We're going to do the rest for all of those wheels and get those assembled. So I pre-assembled all 12 wheels, but for this phase we only actually need 4 of them, so I've kept those here. The other things you will also need for this phase is the wrench that comes in the welcome pack. That's a pretty fancy looking wrench. You will need the XZ plate. Now when you take this out, just make sure that it does slide forwards and backwards nice and easy and there's no issues with that. Obviously we need the wheels. You will also need these things called eccentric nuts. Now if you're unsure what an eccentric nut is, it is basically a nut, but the hole in the middle of it is offset from the center. That allows us to change the pressure on the wheels when we're fitting this to the gantry. I'll explain more about that later. You'll also need a couple of the nylon nuts that we used earlier on. So what we're going to do first is flip this plate over. Now there are a couple of holes in this, we only need some of them for the wheels. Now if you're looking at this from above, you sort of have a small ridge, a medium ridge and then a large ridge. It is the inner hole on the large ridge that we need to put the first 2 wheels in. So we're going to take those, drop them in, make sure the washer doesn't fall off like it did then with me. And we're going to do the same on the other side as well. And then I'm just going to take 2 of the nylon nuts and try and get them on underneath, without obviously all of this falling apart, all of those wheels coming off. Again, you need to make sure the nylon nut goes on the outer edge of the nut. So effectively the nylon part is the last thing that touches the bolt itself. I'll probably show you a little bit better now I've got one on. If I put that there and then just start to twist that on until it grips and tighten it up. And obviously they're quite loose at the moment, so at this phase then you'll just want to take them and start to tighten them up using your hex key and the wrench that came with it. And again, once that's done, you'll just want to make sure that the wheels do rotate freely. If they are not rotating, then you've over tightened the bolts. Just slacken them off a quarter of a turn. Next we're going to put the other 2 wheels in, but these need to go in with the eccentric nuts. Now in terms of the holes that they use, it is the largest ones available. It's basically the ones at the very end on this small ridge here. Now when it comes to putting the eccentric nuts in, as mentioned earlier, the hole in them is offset. There is a thinner side and there is a thicker side. Now when you put them in through the underneath of these holes, you basically want the thinner side as close to you as possible, or to the end of the plate itself. So I'm going to put that in there. Twist it around slightly, making sure, as I say, the thinner end is towards this side of the plate. We're then going to bring the wheel in. This is threaded, so we're just going to tighten that up into the eccentric nut and take that all the way down. Now when it comes to tightening this up, this is the key difference. Use the wrench just to hold it in place. So we're going to put the wrench in place, then bring in the hex key and tighten that side up. Don't twist this, because ultimately you need that eccentric nut to still be facing downwards. So tighten that up, make sure the wheel still spins freely, and that one is good to go. We'll do exactly the same on the other side now. The eccentric nut hole facing downwards. Trying to do this on camera is always fiddly with smaller parts. So there we are, the hole is facing towards me, the lower part. We're going to thread that in place again. Do exactly the same as we just did on that last wheel. Pinch it up, bring that in, hold that in place, and finally just tighten it. Making sure that both wheels still turn freely. Next we're bringing in one of the Backlash nuts that we assembled earlier, 2 of the M5 25mm bolts, and we're going to attach this to the plate here. Now it is fairly clear where it goes. It is the same shape as the plate itself, so it is going right there. So basically we're going to hold that in place. We're going to place one of the nuts bolts through from the underneath, align that up, and then just apply a bit of pressure and start to turn it until it bites with the nut itself. Then I'm going to do that on the other side, get both bolts in place with the nuts. As soon as I can find the hole, no dirty puns. There we are. And again, once that's in place, flip it over, use your hex nut and tighten that up. So we're going to install another Backlash nut, except this time it goes onto this side of the plate. We've got a set of 5 holes here. It is the inner 2 holes. Now move your Z plate out of the way. It will make things slightly easier. We're just going to come in, put a bolt through the underneath, place that through. Now in terms of the Backlash nut, make sure the bolt on this is facing to the inside of the plate. And we're just going to put that on there and tighten it up and start to pinch it up. Bring in another bolt and do exactly the same on that inner hole. Align that up and pinch that up. And again, once it's bitten into both nuts, bring in your hex key and tighten that up. One thing I will just quickly mention, if you're not already aware, obviously when you have things like locking washers on these bolts, you don't really need to over tighten them. Obviously you want to apply a bit of pressure, but you don't want to take them too far because it will ultimately start to cause you issues later on. So yeah, pinch them up and then they are good to go. The thing I should have made very clear about these Backlash nuts is you want to pinch them up so they're held in position, but you don't want them over tight. There should be a slight little bit of movement in them. Ultimately this will help for the next stage when we are threading the lead screws through them. For the next stage, we're combining the piece that we assembled earlier with the plates that we've just built up with the wheels. Now we're going to take this Z plate and ultimately it's got to slide in through that top Backlash nut there. Now in terms of the assembly of this, there is a cutout in the plate. That is the direction it goes, and the longer part of the plate faces away from the linear rail. So I'll try and show you this now. Obviously it's slightly difficult doing it on camera, but effectively that is the way that it goes. Now you just need to put that on top of the Derelict anti-backlash nut and start to give it a few turns and it should bite. Now obviously there are 2 parts to this nut. Make sure it bites through both of them. If it is too tight, then take it back and check the thread is correct. And ultimately, it's going to keep screwing this all the way down until the plate touches that plate, and then we can start to put the M25 bolts in place to hold it all together. There we are. Now it is gripped in both directions. That plate is aligned with the holes underneath. So we can now take these M25 bolts that are again preloaded with the flat washer and the spring washer, put those in place and start to tighten them up. Now, when you are assembling things like this, there is always a fraction of play within the holes. Obviously, it's needed for the tolerances, but just do your best to make sure that everything feels centrally aligned when putting them in place. And ultimately, once that's held in place and then secure, you should be able to turn the coupler that we fitted earlier and it will raise this plate up and down, as we can see here. Now once that is done and you're comfortable and everything is moving okay, we can go back and tighten up the nuts for the anti-backlash nut. So we're just going to pinch those up, make sure they're held in place nice and secure, and that's that part done. Now before we move on to the next section, I will just quickly explain the purpose of a backlash nut because it's quite useful to know. On something like a lead screw, you can potentially get what is called backlash, which is ultimately when there is a bit of play going on in the movement on that thread. Now the purpose of the backlash nut is we can tighten the bolt up there and it will just apply different amounts of pressure, ultimately minimizing any play going on in there. Now fortunately there is no play on that plate, so that is excellent, but in future if you start to find a little bit of play going on in your machine, that's one of the first things to check because ultimately it controls how tight it's running against the thread. Next we're going to put the router mount on to the Z assembly. Now the first thing we're going to do, obviously this comes in 2 separate parts, so we're just going to take 2 bolts, put them in to hold this in position now. And the only reason we're doing this basically is to make sure that we don't lose this front mounting plate. So we're going to put those in and pretty much just tighten them up as far as we can by hand. At this point, they don't need to be tight, as I say, it's purely just for holding purposes whilst we fit all this in position. Now, there are 4 holes at the bottom of this plate here. If I just turn that around, we might be able to see. The bolts are going to come from underneath through the back into the 4 holes here. So we're just going to put that in place, try and figure out the best way to do this for the camera. Maybe on the side there. And we're just going to start to put the bolts through and obviously align them with the holes on the other side. Just start simple, get 1 bolt in, give it a few turns, make sure it is gripped, and then get a 2nd bolt in, start to hold it in place, and it will just make your life easier. Once you've got those in, continue and get all 4 bolts in position. Now, as a quick tip, once you've got all the bolts nearly there and there's still a little bit of play in the hole, stand it up and finish tightening them off like this. Now, the reason for this, it will give you the best chance of keeping this hole that perpendicular with the bed, which is something that impacts the machine later on. Now, we may still need to adjust that, as I say, later on anyway, but ultimately this is the best chance you've got to tighten all the bolts up on the end, keeping it parallel like this. So the Z assembly is done, we've put that out of the way for the moment. We're now focusing on the Y axis. We've brought in the 2 big plates like this and we're going to start putting the wheels on them. So you need your 2 plates, 8 wheels that have already been pre-assembled, and then you're going to need 4 of the nylon nuts and also 4 of the eccentric nuts. We're going to start with the normal wheels first. We'll put those in place. So we're just going to bring 1 wheel in and we're going to start by putting them in the top holes here. So we're going to lift the plate up, drop 1 in, and then bring in the nylon washer nut again with the nylon facing away from the bolt itself. Just give that a few turns, make sure it bites, and that's in position. Now you can either start to tighten them up one by one, or just do what I'm doing now and putting them all in position first, and then I'll tighten everything up a little bit later. So those 4 wheels are in, we'll bring the wrench back in and get those tightened up. And again, making sure you don't over tighten them and that the wheel can still rotate. Now when it comes to the other 4 wheels, I actually have 2 sets of holes aligned. If I just show this to the other camera, what you can actually see is I've got 2 sets of holes here. The ones I'll be fitting it in are these lower 2 here and the same on that plate. So I'm just going to bring one of the wheels in. Actually, what we need to do here is use the eccentric nuts. Now, same principle applies. The thinner side of the hole should be facing towards you if you're assembling in the same direction as me. So we're just going to place that in underneath through the hole. Twist that around again, make sure the hole is facing downwards, then bring in one of the wheels, put that in place, give it a few turns and just make sure that it is biting. And we'll continue and do the same for all of the wheels. Again, just bringing in the eccentric nut, making sure it's facing towards the bottom, bring in the wheel, place it in and pinch it up. There we are. So now I'm going to tighten those bottom wheels that we've just put in. I am guessing the reason there's 2 holes is they may be using 2 different size extrusions depending on the size machine you have. But yeah, same principle. Just bring the wrench in, hold the wrench in place. You don't want to twist the wrench, and tighten the bolt up itself to pinch that wheel, but make sure it is still freely moving. There we are. We'll do the same with the other one. Next step is to fit anti-backlash nuts to these plates. So if I just make that clearer to the camera, there are 2 sets of holes. We're going to be using that one and that one, effectively the 2 lower holes, and those bolts should align as we can see just there. Now in terms of putting these backlash nuts on, we want the bolts on them pointing inwards towards each other. Same principle as earlier, bring in some of the M5 25mm bolts, push them up from underneath, and then let's start to get these backlash nuts fixed to them. Same principle as before, you want them tightened up, but you still want to leave just a slight amount of play in them when we put the lead screw through a bit later. Done the one, we'll move on and get the other one done. So once those backlash bolts have been put on, the Y plates can be put to the side for the moment. Now we're going to focus on the feet. You'll need the 3D printed feet, you'll need 4 of the M525 bolts, and you'll also need 4 of the T-nuts. Now the T-nuts can actually be found in the next bag of nuts and bolts, the one with a lighter green label. Now in terms of putting these in place, what we're just going to do is drop the bolt through, put the hex wrench in, make sure that's gone in position. Now there is a little ridge going on here. Now first thing you need to note is the flat sides of the T-nut need to face into the leg itself, and then you also want the T-nut sitting in this orientation. Effectively, once I can get it in there, just give that a couple of turns, make sure it's biting. There we are. So basically you want it in that orientation so that obviously we can slide the extrusion through and over that. So with that in position, I'll just give that a couple of turns, make sure it's held in place, and then we will do another one. So again, drop the bolt in, make sure it goes all the way through. Bring in the hex wrench, and same thing again, just put it in position, give it 1 or 2 turns to bite it, and make sure it's in the correct orientation like we are there. Finish up the other 2 now. So we've got all of those done, all facing the same orientation. We can now bring in the extrusion and start to fit it to them. So we've got one of the pieces of the extrusion now, and the feet just simply slide in from the end. But we need to do one thing first. Bring in a tape measure, and what we're simply going to do is put a couple of marks on this. The first one you want to make at 33 centimeters in, or 13 inches. I'm going to put a quick pencil mark, and then again the same distance after that. So what would be 66 or 26 inches. And this is basically just obviously to offset the feet evenly. So what we're going to do now, obviously these should just slide in to the extrusion here. If I rotate that round, then the camera picks that up, and then we can just slide that in nice and easy and slide it all the way down to one of those marks that we just put in place. Bring in the hex wrench and ultimately tighten that up until it bites and pulls it in tight. Nice and secure. Do that with another leg. Held in position, we'll do exactly the same now with the other piece of extrusion. If I rotate that one out the way. In case I didn't make it clear earlier, the big scoop out in the extrusion, have this facing up and also have the feet facing up at the same time as well. So there are all the feet fixed to this extrusion. So we're about to start fitting the Y-axis end plates. Now, as you can probably see, everything we're going to be doing is effectively mirrored on each side of the Y-axis. So the first thing we need to do is put the extrusion facing into each other. So the scoop side on the extrusion should be facing into each other. Now, I've got one plate already in place here. We're going to bring the other one and I'll just show you simply how it goes on. Now, the locking nut should face into that scoop. And ultimately the big bow part on the plate here at the back should be pointing towards the back. Just slide it in, make sure the V-wheels go over the extrusion, nice and easy, and once they're in place they slide nice and easy. If there is any resistance, just check that those wheels are moving freely. We will tighten them up later. You will see there's a bit of wobble in them. As I say, we'll tighten those up with the eccentric nuts a little bit later on. Now we're about to fit the end plates. There are a lot of holes in these end plates. The 2 that we're interested in is the top and bottom 2 right in the center, and these go in the holes that are just at the threaded end of the extrusion. So basically the V part should line up dead center with the foot itself. So I'm just going to put one of the bolts in, put that into the thread, and again get the second bolt in place before tightening anything up. And once both are in, we'll make sure they're tight. So fairly simple, we'll repeat that on all 4 corners. So obviously I've zoomed out a bit because we're now working with longer lengths, but the next stage is to put the lead screw on the inside of the extrusion, obviously through the end plates here. So what we effectively need is 1 lead screw, obviously per extrusion. I'm only showing you on the one, obviously basically mirror it over to the other one. So you need the lead screw, you're going to need one of the black locking nuts from earlier, you're going to need one of the couplers that we also used earlier, and you're going to need a couple of the flanged bearings. So what we need to do, obviously there's 2 large holes on either end of this piece of extrusion in the end plates. We're going to take the lead screw, thread it through the hole, and ultimately it needs to go through that backlash nut that we fitted earlier on. So just guide it through nice and gently, make sure it starts to touch it, and then just slowly turn it. You want to turn it in a clockwise direction to grip into that. Now it may be a bit fiddly. If it becomes too tight, you'll probably you've probably cross-threaded it, so don't go too far. And once you've got it in a couple of turns, it should go through nice and easy. And then ultimately you just want to keep turning that till you see it clearly come out of the other side, and make sure it is in there a really good distance. Now once that's in there, this should be able to move back and forth quite freely. We're going to take the flanged bearings, slide one in from this end, place that in position, and then slide one in from the other end as well, making sure obviously that the lead screw is sticking out through that other side, and place that in position as well. And that should ultimately then start to secure it and stop it wobbling about as much. Now obviously we have the coupler and we have the locking nut that need to go on. The coupler goes onto the back end of the frame, the locking nut will go onto the front end of the frame. If you're unsure about the way this is, when you look at the plate that is on the side, the way this is pointing towards the back, that is the back, or shall I say the way that is pointing, that is the back. So we're going to get the coupler on this end first. Again, it has a large hole and a smaller hole. We want the large hole. We're going to place that right on the end of the lead screw all the way in. Grab my Allen wrench, which I moved, there we are. So we're going to place that all the way onto the end, push it all the way in, and then obviously give it a few turns, make sure that is sitting in position. Obviously as you're doing this, the bearings might move about for the moment, but we're just going to make sure that it's held in place nice and tight. Right, once that starts to grip, I say just make sure it is tight. Last thing you want is that falling off. We're then going to put the bearing back in place, butt that up to it, and just make sure that it's sitting on the other end because the bearings fell off. There we are. What we can now do is put the locking nut on the other side. Slightly awkward for me to do from here, so I might as well move around. If I move this into view a bit better, put that in place, bring the locking nut in, and ultimately give it a couple of turns and make sure it is sitting on there nice and tight, because obviously we don't want any play. Now once you have that in position and have turned it a couple of times, bring in your Allen wrench again and pinch that up. Again, there should be no play now in that lead screw. As I said earlier, we're effectively mirroring the process, so once you've done the one, get the other one in place. Align it with the hole and again start to thread it through. Just gently turning it, making sure it is biting through that anti-backlash nut. And once you've got it in a couple of turns, it should become a little bit freer and go through nice and easy. Again, I'm going to put a bearing in place, slide that in, put it in the hole, bring the coupler in, place that over the end and make sure that is pinched up nice and tight. Push that all the way through to the other end and go around and put the bearing and the locking nut on that side as well. We're getting ready to start connecting all of these up. Obviously we've got the Y-axis that we've built and we've got the X-axis gantry here, but we need to put the drag chain plate on first. Now if you're unsure of the orientation of this, I'll put a photograph on screen now just to make it clear. But ultimately we need this plate, we need the M5 10mm bolts, which again can be found in the pack with a lighter green label, and we also need the T-nuts. So what we're going to do is into the two holes on here, we're just going to drop the M5 10mm bolts, put the T-nuts on a couple of turns, do both of them together. Make sure the T-nuts obviously again are in the correct orientation in relation to the bolts itself. Give them both a couple of turns. Make sure they're also same orientation in terms of facing the same direction. Just make it slightly easier to slide into the extrusion, like I'm clearly struggling to do now. Now with that in place, put your thumb underneath and just sort of butt the T-nut up to your thumb, and that is basically roughly where it needs to go. Hold it in position and then pinch those nut and bolts up. Make sure it's held in place. And that's that piece done now. We can move on and start to assemble all of this together. Now at this point, the size of this machine starts to become very real. We've got to fit the X-axis gantry to the Y-axis. Obviously we need to make sure everything is spaced out correctly. We're going to start on the side that doesn't have the drag chain, and the scoop of the X-axis gantry should be facing towards the front of you. So basically I'm going to move all of this across, get 4 bolts in on this side to hold the gantry in place before we move on. It will be the M5 25mm bolts to hold this, and obviously the holes will align with the plates on the side. So when attaching it on that side, I found it easy to rest it on the extrusion this side, obviously just to help keep it a bit more parallel. Now we're going to be dropping the Z assembly on this. Obviously there are the same grooves for the V wheels, so drop those in place and it should, all being well, slide on pretty easily. Next, obviously we need to attach the plate to the X-axis gantry. It is just generally better to have the plates as aligned as possible, so I'm going to pull this all the way back, get 4 bolts holding this all together. Just to be safe, I will bring a tape measure in to double check the measurements. The more accurate it is when you are assembling, obviously it just makes life easier because it keeps everything square. So that is 51 centimeters. I'll make sure this is getting close to about the same. It's probably gone a bit too far there. There we are. So it's pretty close now. I can get the bolts in and they should all hopefully stay as square as possible. We're now going to move on and put the X-axis lead screw in. Obviously this is the only one remaining. It's also bigger than the other ones. The other thing I should point out as well, same process as earlier with the other lead screws, except we're now using the bigger locking nut, the bigger coupler and also the bigger flanged bearings. So we're going to do exactly the same process, thread this in, put all the bearings in place and then we're good to go. Now at this point I've just realised I made a very big mistake. When building the Z assembly there was a larger backlash nut, obviously because the X-axis lead screw is much larger, so I actually should have fitted that one instead. I really should have realised, a dumb mistake on my behalf. I will get it swapped over now, but I will point this out when I edit the video so people don't make the same mistake. But yeah, let's get this swapped over and the bigger one put in place. So with that changed over, let's try this again and get the lead screw in place. Same as earlier, bring in the flange bearing, obviously using the large one this time, place that in, get it into the hole, then bring the coupler in, using the large hole, place that over the thread, get it in place, hold it tight, make sure it is sitting in there well, and then again tighten up that bolt, making sure that the coupler is clamped onto it nice and tight. Now I should say that when you are doing this, there is a you can think it's tight and it's not quite gripped, so do just give it that extra little quarter of a turn, make sure it's pinched in nice and tight and obviously grip in that thread. We're going to push that through to the other end, take the other bearing down as well as the larger locking nut and tighten it up on this side as well. Put that flange bearing in place, pull the thread towards us, and then again we're going to put the locking nut on, but we're using the tapered end going into the thread first. Give that a couple of turns, make sure that again pinched in place, and then finally lock that one in, and it should hold this all together nice and tight. There we are, everything now nice and secured. Well, yeah, the machine's starting to come to shape at this point. Now at this stage we're going to move on and start to install the stepper motors. Obviously you need the 4 stepper motors, you need the spacers, you also need the 50mm M5 bolt. Now adding the stepper motors is really easy. Obviously there's 4 bolts, they go through the holes, the spacers should then go on next. You need to make sure the stem of the stepper motor goes into the coupler. Now if you're struggling to get it in, make sure the coupler is fully released and it should drop in fairly easy. Now in terms of doing this, obviously I'll show you on the Z assembly. I'm just going to put one in place to begin with, drop that in, put it in the hole, and then we're just going to tighten that one up. Just give it a couple of turns, make sure it is sitting in place and starting to bite. Then we're just going to go around and add all the other ones in. Obviously, given the Z assembly and gravity, it's probably easier to put this in place and then drop all the bits in afterwards, rather than trying to tip it upside down and effectively everything will fall off. So we've got 2 bolts in. I'll just move around and do the other ones now. Get the spacer in first, drop the bolt through in place, and give it a few turns, make sure it is biting. In terms of the wiring for the Z assembly, you want to make sure the wires are facing towards the back of the machine. And once you have all the bolts in, just go around, pinch them all up one by one, make sure they're tight. Now once those are all on and this is secure, it's now time to come back in and tighten the bolt up on the coupler. So again, just come in with the Allen wrench and start to tighten that up, and you'll feel it just tighten and start to grip onto the stem of the stepper motor, and make sure it is gripping, tighten it up. And there we are, that should now be fine. If we turn the coupler, obviously we should see that the axis rotates, and that is all good, and it's also turning the stem on the motor as well. So we'll move on now to the same for the other 3 stepper motors. The X and the Y are slightly easier because obviously you can pre-assemble it and gravity is not fighting against you so much. But again, same principle, you want to make sure that the wiring is facing towards the back of the machine. On the X, we're just going to get one in here. Make sure that goes into the stem of the coupler again. Get one in place. Can be a little bit fiddly. There we are. Just give that a couple of turns, make sure that is holding, and then move on and get the others done. And again, once those are tight, just come in and finish off with that coupler. Make sure that's tight, and then just test again that everything rotates nice and freely and it all moves. Move on and get the Y done now. Next we need to prepare the drag chains. The first thing you'll want to do is pop the ends off that have the screw holes. You can just get something like a screw or an electrical screwdriver in here, prise one side open, and it should then come off. The next thing we need to start doing is lifting all of the cage covers on the drag chain itself. Again, use something like a screw or an electrical screwdriver, just pop it in, pop it under there, and it should pop up like that. We're going to go along and do that for all the drag chains. Basically, you should end up with 4 of these ends and all of the drag chain open. Next, you're going to want to take the T-nut, slide it in at the end, and move this down to probably just before about halfway. You're then going to bring in one of the ends of the drag chain, the 10mm bolts, and ultimately just put that into the T-nut to hold it in place. We're doing the same again. I've just slid a T-nut in from the other end of the X-axis. We're going to bring in the other end of the drag chain, drop the bolt in and put it through and just pinch it up to that T-nut. Give it a couple of turns, make sure it's gripped, and then slide it all the way down to butt up with this. We put the final part on the Z-axis, making sure it's pointing back towards the female end at the opposite side of the gantry. Now on your 2 drag chains, you'll have a long one and a shorter one. The long one is for the X-axis, the shorter one is for the Y-axis. Now we need to take 13 links off this in order to make it the right size. So let's count them out. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Basically we want to snap it at this point and take those 13 links off. Now you can just twist this and it comes apart fairly easily, and you can keep those for later. They can sometimes be useful for other projects, but ultimately we should now have 2 drag chains that look like this. Short one for the Y-axis, long one for the X-axis, and we'll get them put in place. We're going to start with the X-axis. We're just going to pop the drag chain back in place on the one end for now. Just prise them a little bit apart, push that in, and it will click back in place. And there we are, good to go. What we'll start to do now is put the wiring in place, put the router in place as well, and then obviously we can close all of this drag chain up and complete the X-axis. So if you haven't done so already, take your router out and we're going to drop it into the holder. Now technically it does look fancier having the Makita on the front, but actually the wiring goes in from this side, so I just generally find it easier to have the router sticking out that side. Going to lower it down, probably about 3/4 of the way down the diameter of the shaft itself, and just pinch it up and hold it in place. Now what you can do at a later stage is obviously adjust the height of this as you need. If you're going to be having things like a dust shoe that connects to it, you may want it lower, or ultimately you can use it to adjust the depth. But for now we're just going to leave it there, pinch it up, make sure it is nice and tight. Now obviously you will see as I'm tightening this, this is still rocking about. We'll sort this out later by tightening the eccentric nuts up. So with that in place, what I'm going to do is just take the rest of the cable in, and we're going to start to wrap it round and feed it through the drag chain. If you have induction sensors, now is the time to fit them. Basically what you'll want to do is put the nut on a couple of turns, bring it so far down, then put one of the washers on, slide it through the back hole, And ultimately what we need to do is just make sure this comes close to the black plate but doesn't hit it. So it needs to be maybe 1 to 2 millimeters away. And you can judge this by just turning the coupler itself to raise it up and down, and ultimately make sure you are close but not hitting it. When you think it's in the right place, just place the washer on the other side and also place the nut on. It can be a bit fiddly, so if you think it's in the right position, you can always lower the Z axis back down before you try and get this nut in place. There we go. Now I can just get this on, give it a couple of turns, and ultimately you want to pinch the nut up on the front and the back. Just make sure it's all held in place. Next, take a look at your wiring looms. I had one on its own and then a few wrapped together. We're going to be looking at the one on its own. We're going to connect this to the back of the Z stepper motor. It is fairly simple to do. It will only go on one way. Push it in, make sure it clicks. Now what we can do is we have all of our wiring in place, so we can feed this through the drag chain and ultimately connect it back up correctly. Now the best way to do this, in my opinion, is bring all 3 wires together. Obviously you want to make sure that the router has enough space to move up and down, so do give that a little bit of slack. Place it over into the original drag chain holder, and then bring this back over, and you can then start to basically judge the distance of it. You can put the first clip in under and around the cable in itself, and ultimately then clip that back in place. A little bit of pressure, wobbling it side to side, and it goes in, and just put the first clip underneath in, obviously to hold it in place. Now what we can do at this point, obviously we've got a good idea of how much cable we really need in terms of everything, and just start to feed it around the drag chain and making sure it is all seated nice and comfortably inside. Obviously we're going to need to fit an extension to the router because I don't think it's going to finish this, but we'll go through and just start to clamp it all in bit by bit. As a quick tip, instead of doing every single fastener, what I normally do is go 5 or 6 along, put one in, just hold it in place, then carry on round, do another 5 or 6 and so on. And then once you're comfortable that all the wiring is in place, you can ultimately go around and lock the rest off in place. I have just realised I've fitted this a bit too far down, so I'm going to pull this back a little bit and you'll see why in a second. The reason I pulled this back is very shortly we're about to extend the router cable and the sensor limit cable. Now the cable for the stepper motor, this should be long enough, and if I didn't mention it on the last clip, make sure you use the longest cable out of all that are in the kit. Now when we extend these 2 cables, there's going to be a little bit of slack because ultimately we want to keep access to both of these connections. So there are these 2 3D printed parts that come in the kit, and these ultimately just clip onto the back of the extrusion. They will take a little bit of pressure to get into place. And we'll put the second one in. And now what we can do is, once we've extended these cables, is just take some of the slackness and zip tie them in place so they're not just dangling around. At this point you'll want to take the 2 extension cables that you have, one for the limit sensor and one for the router. So we're just going to get these connected up for now. On these clips there are 2 holes. If you put a kink in a zip tie like this, pass it through the bottom hole, it should then come straight up out of the top hole, and it will allow us to zip tie the cables in a second. Now ideally you want to try and keep the 2 connections somewhere to the right hand side of this, so you approximately have 1 to 2 foot worth of spare cable. Just put these into a bit of a loop and try and get them into the zip ties and resting on these holders. And then we can just pinch everything up and it should hold all of these in place nice and securely. Also, as a bit of advice, you can get away with a bend in the cable, but make sure it's not pinched so tight that it puts a crimp in it, as that could damage the cable. Take one of the shorter stepper motor cables and get this connected up. If you are fitting the limit switch sensors, now is the time to install the one on the Y-axis gantry. This is in a similar process to earlier. Put the nut on first and the rougher washer, slide it in place. This one is a little bit tight. Once in place, then put the washer and the nut on from the other side and begin to tighten it up. Now, as my carriage is further down the axis, I'm just going to leave that sticking out for a bit for now, and I can always readjust that later. Now at this stage you have two choices when it comes to the X-axis drag chain. You can either start to put all of the cables into the drag chain and clip it up and then fit the drag chain in place. Alternatively is the opposite way, which I prefer to do, which is get the drag chain sitting in place first and then feed the cables into it, so it should sit more comfortably and you don't have to worry about twisting anything around. Now a really useful tip at this stage, just take the cable that is already in place for the Z-axis stepper and simply mark on it with a Z. Now this will come in very useful later on. And also if you're doing induction limit switches, do the same with that connector. Just mark a Z on that, as saying it will just make life much easier later on. Also at this point you can now see if your drag chain is running in alignment from the top to the bottom. Mine is pushed out slightly, so what I'm simply going to do, slacken these two bolts off just a little bit here, to release them a little bit, and then I'm going to push this bracket back inwards so that this drag chain aligns from top to bottom. Now I've got that aligned, I can pinch this back up. So what I've just done is manually move the gantry forward that way to make sure that the stepper motor isn't interfering with the drag chain. We're now going to feed every cable through the drag chain individually, sitting it all neatly inside and making sure nothing is twisted. Now if it's easier, as you start to put them in, you can just lift a couple of these up just to hold it in place until you're ready to get the next cable in. As you come to feed the last cable through, you can then start clipping these in place just to make sure that everything is definitely held. So we'll get that one done, feed it in a few more, get that clipped, and we'll just finish off the rest of the drag chain. And again at this stage we're going to install the limit sensor. Now this is based on homing towards the front left hand corner. If you plan to home in a different corner, then obviously your sensors need to go in the relevant corner for that. This one also fits slightly differently. It goes underneath the gantry under here. You should have had an extra bracket, and we've got a bolt and a T-nut provided. So we're just going to fix the bracket underneath here. It should go in this orientation, allowing the sensor to ultimately fit through there and stick underneath the gantry. So the first thing we're going to do is to get the T-nut in place. We're just going to slide this in, pull it further underneath. I should point out, you can see that I've lifted the height of the frame up on this side. The only reason for that is to get the Allen key in underneath. So once we've got that T-nut in, we're going to put the bolt in and find where it goes. Right, there we are, that's in a couple of turns now. Now I'd suggest putting the limit sensor into the bracket first before we go any further. Same process before, take the one bolt off, or one nut off I should say. Remove one of the washers, place it through the bracket in this orientation, and then put the washer and then bolt back on from the other side. Now again, as earlier, these can be adjusted later on. So it's more about just getting them in position for now, and then they can always be tweaked a little bit further down the line. So with that in position, you want it to be as close to the end plate as possible. So we're going to put this in, make sure it is in the bolt itself, and then just pinch the bolt up, giving it a few turns. And once it starts to get tight, bring your Allen key in and just give it that extra turn to pinch it up. Now at this phase, if you're assembling the smaller machines, you will have 2 stepper cables left, but obviously if you're assembling the larger machine, you should have 3 stepper cables, which will be 2 short ones and 1 long one. Now technically you can use any 2 of those cables to wire up the remaining stepper motors. Obviously the one closest to the drag chain, make sure you use one of the shorter ones for that, so we're just going to get that connected. Then in regards to the one furthest away, as I say, you can use the shorter cable, but ultimately you can also use the longer cable in case you want a bit of extra play in order to mount the box elsewhere. So we're about to start getting the cables connected to the CNC longboard. This is fairly simple. All the terminals are marked up, whether it's the X, the Y or the Z, and also depending on whether it's the stepper motors, which is the wider green connections, or the limit switches, which are the shorter white connections. Now as I mentioned earlier on, we should have marked them up with pencil to make our life a little bit easier. So this is for the Z limit switch, which is the one right here. So I'm going to get that plugged in. And again, they should only go in one way. making it a very simple connection. So if that is for the Z, then this is obviously for the X. So I'm going to connect that to the X limit switch. And I'm also going to bring the cable in from over here just to connect the Y limit switch. I will tidy this wiring up a little bit later on. Get that in place. And the same process for the stepper motors. Now, whilst all the connectors should come wired up correctly, it is worth double checking at this point. Now, with the screws facing upwards, it should be blue, yellow, green, red for the order of the wiring. This one is for our X-axis, which is here. Push that in, make sure it clicks. This one is for the Z-axis. So I'm just going to push that in, make sure that clicks. Now when it comes to the Y-axis, you obviously have two ports for the Y1 and the Y2. Now it doesn't make a difference really which one they are because they should run simultaneous. Ultimately it's just for you to remember. So what I'd probably say is make the closest one Y1 and then the furthest one away Y2. So for me that's Y1 here and we have Y2. Now in terms of the power connection, this is the port that is on the side there, so I'm just going to plug that in. And the connection on top is for the emergency stop button, so again I'll plug that in. Now obviously at the moment everything is looking a little bit messy, so what I would probably say at this stage is start to go around and tidy your cables up either with some zip ties, some velcro ties, just ultimately to keep everything much neater, because when the cables start springing like this they will just bunch everything up and make it messy. There we are, we're starting to get some order to that chaos. Now I'm a fan of recycling things, so I've just used the original black ties that held all the cables together in the packaging just to pinch everything up for now. I will probably replace those with Velcro ones later on, but ultimately it allows us to keep this a bit tidier as we continue to set up. Now very shortly we're about to get the power connected for this machine, but before we do so just do a couple of very basic checks. The first is to make sure that the gantry is still perfectly equal on both sides. So again, just take a tape measure, measure the distance from one side, measure the distance on the other side. Mine is a little bit out, I'm just going to wind that in. There we are, that is now much closer, much better. Also go around and just tighten up the remaining backlash nuts that we left loose earlier on. Just pinch those up because ultimately we're going to start to calibrate this very shortly to make sure everything is running square and smooth. It's now time to get everything plugged in. If you are in a country that uses 110 volt, that is absolutely fine. The power pack that comes with the CNC LongMill is a 110 input. If you are elsewhere that needs 220 volt, you'll either have to use something like a downstep voltage converter that I have here, or replace the PSU with a different one that is set up for 220 volts. As I say, I'm using this downstep converter, so I'm going to get everything plugged in now. Make sure your emergency stop button is in the open or released position. If you're unsure what position it is in, simply press it down, you'll hear it click, then turn it to release it, and that is in the open position. Connect your USB cable and connect the other end to your PC or laptop. At this point you'll want to head over to cnc.com/Gsender to download the latest version of their control software. Before I do this, there is another page which guides you through the installation should you have any issues, and a few links down below to extra resources if you are struggling. But from the Gsender page, scroll down and you can see the multiple download options depending on what platform you are using. I'm using Windows. I already have this downloaded to save some time, so I'm just going to open it up now and begin the installation. Should you get presented with this screen, it is a safe app to continue, so we're going to click More Info and Run Anyway. You may be presented with an additional security screen, just click Yes and Continue. Work through the various pages for the setup, click Install and let it do its thing. Depending on the speed and power of your machine, this can take several minutes to complete the installation. Once it is done, you will be presented with a screen like this. You can click the Create Desktop shortcut and Create Start Menu shortcut to make your life easier to find Gsender later on. I'm also going to leave the Run Gsender ticked because we want to start that up now. At this point, if not done so already, connect your USB cable to your PC or laptop. Then go up to the top left hand corner, hover over and come down to the device that's showing. Should look something like this. You may see a different COM number depending on your machine, but that can vary. But ultimately you should see something along these lines, GRBL 1152 for the baud rate. Click that and do the connection. At this point you should have some very basic controls of your machine. Just do a simple test with a small increment like 5mm as we can see here, and check it moves in every direction. I'm going to go right, I'm going to go left, we're going to go back, and we're going to come forward and raise the Z-axis up 2mm and down 2mm. At this point everything is going to be running quite loose on the machine. We need to go around, dial it in by tightening up all of those eccentric bolts. I would suggest starting by jogging your machine all the way over to the far right front corner. Initially when you're doing this it may sound like something out of Jurassic Park, but the more we dial it in the smoother it will run. Now it's time to go around and tighten up all the eccentric bolts on the wheels. Now when we installed these we left them in the most open position so it wasn't putting any pressure on the wheels. All we simply need to do is bring in the wrench and start to rotate this around a little bit, and you should start to feel it tighten up. Now at most this can only go 180 degrees round to be as tight as possible. So start to rotate it and you should start to feel the wheel pinch up against the rail itself, and to the point where you then can't twist it with your hands. Now if for any reason the bolt loosens at the same time, you can always come back in and just pinch that up with the Allen key with a slight quarter of a turn to pinch it back up. But there we are, I now can't turn that wheel with my hands. You don't want to over rotate this eccentric nut, so just start in smaller increments, maybe an eighth of a turn or a quarter of a turn at the most. And once you can then no longer rotate the wheel with your fingers, it should be good and holding enough pressure against the rail. Continue around and do that with the other eccentric nuts as well. Now it is a balancing act between the two wheels. As you tighten one up, the other one may become looser. So go back and do double check them. And obviously if it does become a little bit loose, just give it a fraction of a turn to tighten it back up so they're both equal. Exactly the same principle on the Z-axis. Just bring it in again and turn it quarter of a turn or so until it starts to tighten up. Now the difference with the Z-axis is you can literally feel the wobble in this, and you want to take as much wobble out as possible. You may need to go more than that, but just start to do it until it tightens it up. Do both wheels equally, so do a little bit on one, move over to the other side. Now to make my life easier, I did just move this off the end plate to allow me access to the eccentric nut here. These have been rotated around 120 degrees from their original position, so when they were facing down, they're now facing up in this direction. Now this is solid though, there is no wobble, there is no movement. What I would say at this point is if you over tighten these bolts, it will wear the wheels down quicker. So you do want to find that balance with it being tight enough not to move, but not too tight that it's going to wear. And when they are in position, then everything should still move freely by turning the lead screw. Once all of the eccentric nuts are tightened up, just manually check that there is no wobble and play. Obviously, if there is a little bit of movement, just go back and check. What you may find, for example, on the X to the Y axis, is if you push this back, one wheel may become loose. So you may just want to give that an extra pinch up. But this is looking pretty solid at the moment. The only movement is in the actual table. Now at this point you should have already tightened up the bolts holding the Backlash device, but what we need to do is just make sure this bolt isn't loose in here. Now the way a Backlash device works is ultimately it stops the free movement in this to hold it nice and tight against the lead screw. Now as these are brand new, there shouldn't be any movement in them, but over time this is one of the parts that will eventually wear. What we just want to do for the moment is make sure the bolt in here is at least touching the inside of it. So just go in with your Allen key, give it a few turns until it starts to go all the way down to touch the Backlash bolt. And once it starts to tighten up, you are good to leave it there. Now, any machine like this, you should have some sort of weekly maintenance schedule, and these are the type of bolts you'll want to keep an eye on as part of that, just to make sure they don't wobble loose. Repeat the same process on the other side, just tightening it up turn by turn until you get to the point it starts to bite and hit the inside of the Backlash nut. Same for the one on the Z-axis. I can get this with my finger, so I'm just going to tighten it up until I can start to feel it pinch. Just give it a slight turn with the Allen key, and that one should be done. Now the one behind here on the X-axis is probably the most awkward to get to, so we're going to lift this up all the way and try and come in from the side. This one by far is the most difficult to access. You can either come in from the side if your Allen key is long enough, or try and get in from underneath with the shorter end. It will be difficult, but persevere and you will get there. Now with all the wheels tightened and the backlash nuts tightened, just go around and jog the machine about again. Make sure everything moves freely. If anything is stiff or jamming, just release them a little bit and you'll start to find it moves easier. Now the next step is really important. It is all about getting the frame as square as possible. What we're going to do is start on the right hand side of the machine as you're looking at it. We're going to fix this axis down here. Now start by fixing down the feet on either end and then fixing down the support legs in between. Do remember these are plastic, so don't screw into them with too much power or you will break them. What we're then going to do is perform a series of checks to make sure that the other end of the machine is square and parallel to this. Now obviously if you're mounting this onto a bench, try and use this as a guide to help start to get everything square. Roughly position it where you want to be in both directions, left and right, forwards and backwards. Then take a tape measure and just make sure the distances are equal. I have 69 millimeters here, and that is less, so I'm just going to move that in quite a bit. Go back and checking them. Now, when squaring this up, you may need to move the other legs as well, obviously to twist the machine around. So I'll just move around and do that now. Now, the more time and care you spend doing this, the better it is going to be for the accuracy and running of the machine. So that is pretty much set in place for me now. I'm going to start by putting one screw in here and then one screw in here and just check the measurements as I go along. I will also point out there are multiple sets of holes. This is so you can adjust them if you need to later if the machine is not quite perfect. So with those two in now and the measurements are set, I'm going to pin these two in place as well. And then just put an extra screw in either end of both feet just to secure this one side down. Now at this phase there are potentially two things that could go wrong with the y-axis. They could be parallel but offset like this, or alternatively they could be pointing in or out towards the back. Now the way we need to do this is similar to what we did earlier by checking that the machine is square. So we're going to come back in with a tape measure and go corner to corner diagonally and take the measurements. Now quite surprisingly that is squarer than I was expecting. That is within 0.5 millimeter, which is pretty accurate for this layout. So what I'm now going to do is pin this front corner down with a screw. We're then going to jog this x-axis back and make sure it stays in position as well. Obviously every time you fix something down, just check the measurements that it all remains square. So everything is fixed down, that is running nice and smooth and square. I'm just going to put the remaining screws in the end plates and the middle legs for the supports, and that is essentially everything set up. Now we can jog the machine about. We can also dial in the sensor switches. Now what you ultimately want to do is bring the axis as close as possible, but obviously without touching anything. Then what we're going to do is adjust the limit sensor and push it as close to that plate as possible, again just leaving a very short gap. So what we'll need to do is just come in and loosen off the bolts that we tightened up earlier. Shouldn't take much to release them. And we're going to thread this back a little bit and just start to feed it through until it gets close to that plate. When you're pretty happy with it, tighten everything back up and just pinch the nuts back up. If you're unsure how close the sensor needs to be, there is a red light on the back which indicates when it has been activated. So for example, we can see there is a little bit of a gap there, but if I jog the machine away, it is now inactive, and when I bring it back in, it activates it. So that is just an easy way to understand of how close you need to get the sensor before it will engage. Repeat the same process for the Z-axis as well as the Y-axis. If you are nervous about hitting the plates on the front, you may want to pull the limit sensor just back a little bit to give you that extra wiggle room. Now once that is done, we need to jump back onto the PC to turn on the settings in order for it to know that these limit sensors are installed. Once you've adjusted all of your limit sensors, make sure that none of them are engaged. So just jog everything away from them a little bit and make sure there are no red lights on. Then in Gsender, we're going to come up to the firmware option and click on that. We're going to scroll down a little bit till we get to these menus just down here where it says hard limits and home in cycle. We're going to turn on hard limits. This ultimately is the safety feature to enable the sensors, and we're also going to turn on the homing cycle. This is just a useful feature and ultimately another reason to have those sensors. With those both turned on, we're going to click apply new settings, and what we will see in the background that just happened then is a few things changed. We're going to close this menu down, and by default we can just see the home signal is in the bottom left hand corner for how this machine has been set up as default. As mentioned earlier, this can be adjusted and there are videos on the CNC website advising you how to do this, but for now we're happy with this. But let's test the limit sensors and make sure they work. So I'm just going to jog this across, and all being well it should engage the limit sensor and we'll get an alarm flag up on screen. There we are, we can see the red light has come on. We've got an alarm on screen to say that we've activated the sensor, and therefore we can't move anything else now until we unlock that. So we'll simply click to unlock on the alarm. And there we are done. Now for the most part that is pretty much done, but I wouldn't say go and dive into a job too quickly. The machine does need to be bedded in. Start to just jog it about a little bit and see how it runs. You may find that things tighten up and become noisy. You may find that things loosen up and need adjusting, and just go around and obviously counteract anything that needs to be readjusted. The nuts on the end of the lead screws, for example, they might need tightening up now that everything is in place. And ultimately this is where you start to get into a maintenance routine, either daily or weekly, whatever it needs to be, of just checking the relevant nuts and bolts and the connections and making sure everything is good, and also applying things like dry lubricant to the lead screws. This will help them move freely and also minimize noise. But at the end of the day, well done, you've just built your LongMill MK2. I do hope you found the video useful. If you did, please make sure you like and subscribe to the channel. Thank you very much for watching. Final thanks as always goes to my patrons. If you want to get involved for one-to-one help, early access to content and giveaways, definitely check out the Patreon links in the description area below. I will see you all on the next episode.